Assalamu alaikum. Today we'll be going over the specimen paper for 9618, which is for computer science, the new syllabus, and it is for examination from 2021, right? So we'll be going over this paper. So the first question states, state one difference between a kibibyte and a kilobyte. So kibibyte is 1024 bytes. Kilobytes is 1000 bytes, right? So now it says give the number of bytes in a MB byte. So MB byte is 1024 kilobytes multiplied by 1024, right? That is your answer. Now it says complete the following binary addition. So we'll say 1 0 1 1. So 1 1 becomes another 0. The 1 1 1 becomes another 0. Now this is a triple 1, so this becomes a 1. 1 1 becomes another 0. 1 1 becomes another 0. 1. So another triple 1 becomes 1 1, right? So this becomes 1 1 0 0 1 triple 0 1, right? So now it is asking for an error that occurred when you added the binary number. So if you can see, these are 8-bit binary numbers, but your result is coming out to be 9 bits, right? So this causes an overflow, right? So we can write an overflow occurred and the answer cannot be represented in the current number of bits. Right? Okay, so now it is asking us to perform binary subtraction, right? So we're going to change the number into 2's complement first and then just add it, right? So that is the easiest way you could do it. We'll be working along with this number, so I'm going to flip it. Right, so that is my flip. Now I'm going to add 1 to it to change it into 2's complement. 0 1. So this becomes a 1 1 0 0 1 1. Okay, so now I have to do the addition because I've changed this into 2's complement, right? This is 2's complement, right? So 0 1 1 0 0 triple 1 plus now 1 1 0 0 1 1 1 0, right? We're gonna do addition on this, right? So 1, this 1 1 becomes this 1 1 becomes a 0, triple 1 becomes a 1, 1 1 becomes a 0, 1 carried forward, 1 1 1 1 becomes a 0, 1. In this case also, this is an overflow of some sort, right? So your answer becomes, oh sorry, this will become a 0 here, sorry, 1 0 1 1 is a 0 and then 1 is carried forward, right? So this is your final answer for this, right? So this is your binary subtraction in the in terms of doing it by using 2's complement method, right? So we're now going to move on to question number 2. So this is related to networking. So I'm going to add this networking. So this guy runs a company that books walking holidays for a group of people. She has a website that the customer uses. So the website has a URL and an IPv6 address, right? So now we need to, and the question is asking us to describe using an example the format of an IPv6 address, right? So first of all, I'm going to write them down in bullet forms. An IPv6 address contains a set of 8 numbers, right? So it contains a set of 8 numbers, right? So the next part is that each number is 4 hexadecimal digits, right? After 4 hexadecimal digits, there is a colon to separate the other 4 which represent another of the 8 numbers. Okay, and now lastly we can write an example, right? Because it is asking us for an example. So we're gonna write example. So I'm just gonna write random stuff. This is 1, right? So in this example you can see that there are indeed 8 numbers and they are of 4 hexadecimal each, right? So I'm gonna erase this now. So that is a valid example, and in this example you need to know that hexadecimals do exist till F, so do not use any letters beyond F, right? So it's going to be marked wrong, so your example may become wrong, right? Okay, so now it's asking that an IP address can be static or dynamic, and we need to describe static and dynamic IP addresses. So a static IP address is assigned by your ISP. So is assigned by your ISP. So this is a really important detail, right? Or the server, right? So or the server. Okay, and now you need to know that when a computer disconnects and reconnects to a network, so when a computer disconnects and reconnects to a network, the address remains the same, right? The address remains the same. So this means that your IP address, when it remains the same, so that means it is a static IP address, right? So now we'll move on to dynamic. So you can guess yourself, a dynamic IP address can change, changes every time you connect and disconnect. So we're going to write the same thing, but a dynamic IP address is assigned by the network OS. So it's assigned by network OS. I'm just gonna copy this here. I'm gonna copy this here and just mark the significance of this address changes each time. Changes each time. So I think this was 4 marks. So this is a very gaining thing. Even if you just know the definitions, you just need to know how it is assigned and what it is, right? So now we move on to describing the characteristics of a LAN, right? So what is a LAN? So you can know that it's already given it as a local area network. So LAN, how is it created? So a LAN is created when devices are connected over a small geographical area, right? So they're connected over a small geographical area, and an example of this can be inside your own house, right? Because you are living in a small geographical area as compared to bigger terms like a metropolitan city or a university, or even have a wide area network like connecting multiple cities or multiple countries across the globe. So it's a very small geographical factor, right, where you are living. So an example can be a house or a small office, right? So if you have a small office, so you can have a LAN there as well, and with its own dedicated infrastructure, right? So this means that you have your own router and that is connecting you to the internet, right? Okay, so now the LAN has a range of different topologies, right? One subnetwork connects 4 computers and one server sets up a star topology. Now we need to describe how packets are transmitted between 2 of the computers in this subnetwork, right? Okay, so first of all, we need to understand how packets work. So, right, so the packet of your data has the address of the recipient. So it has the address, right? And the sender, when it sends, right, the packet, the sender transmits the packet directly to the server. So it transmits your packet directly to the server, right? Okay, so now the part comes in where your server figures out, right? So the server reads the address on the packet, right, and identifies where the recipient is, right? So the server reads the packet and then identifies where the recipient is. So take, for example, you have the address 23 on this packet, right? So this is your packet. So here your server is, and you have multiple computers, 24, 23, 22. So when your packet is transmitted to the server then figures out and then transmits it to 23, not 22. So therefore, that is how it gives your data to the correct computer, right? Okay, where the recipient is, and transfers the packet directly to them. Right? So even this is for 3 marks, right? And now we have the LAN. We're going to read part D. The LAN has both wired and wireless connections. Ethernet cables connect the computers to the server. Identify 3 other hardware computers or components that might be used to set up a LAN. So this is basic general knowledge. So you can have a router, you can have hub/switch, and you can have a network interface card. Also known as NIC. Okay, so I think this is the last part of this networking question. So it says describe how carrier sends multiple access, collision detection, manages collisions during data transmission. So this is something you need to be aware about. So you have a channel through which you forward data, right? So the computers, so this is how the computers work. So the computers listen to the channel, right? And they search for noise. Noise is basically when data is transmitting, right? Listen to the communication channel. And so this can be the communication channel, right? So they listen to the communication channel. If there is no data being transmitted, right? If there is no data being transmitted, so the computer that was listening can transmit its data, right? So if it is noise free, then you're well and good, go ahead, send your data, right? So if a collision does occur, right, if a collision does occur, because this does happen, right, it doesn't happen that often now because we have better technology, but it used to happen a lot back then, right, when you were developing your networking, right, in olden ages. So if a collision does occur, right, so each computer then waits a random time and then transmits their data again. So this is how this works, right? So this was for 3 marks. Okay, so this is one of the best chapters there is to AS. So this is databases, right? So Marad has a holiday company database that includes data about holidays, such as the location, date, duration, data about the customers and the holidays they have booked. So Marad is a normalized database, right, with just 3 tables. Draw an entity relationship diagram for the 3 tables. So we can have customer here, we can have the booking here, and we can have the holiday here, right? This is a customer books the holiday, right? So this can be one too many. This is gonna be a straight line, my bad. Okay, so this is gonna be one too many, one customer, many bookings, right? And this is gonna be one too many as well, because multiple bookings of the same holiday can be done, right? So this is how it is, the entity relationship diagram. So this represents one too many, one too many. Okay, so you do not necessarily need to write this. This is not what you write. I'm just writing it here for the sake of explanation. Okay, so complete the table to identify the primary key and the foreign key for each of the tables you identified in part A. If the table has no foreign key, then write none, right? So we have the customer table, we have the holiday table, right? And we have the booking table. So we have these three tables, right? And so for customers, we're gonna have customer ID for sure, right? Customer ID. And as you can see, there won't be any foreign key, right? And holiday ID. And there's gonna be no foreign key here as well. But for the table booking, so you're connecting customer to booking, holiday to booking, right? So one to many. So many represents there will be a foreign key from holiday inside of booking that is connecting the two, right? So for booking, the primary key will be booking ID, but the foreign key will be customer ID and the holiday ID, right? So this is how it's gonna be. This was for 3 marks, this was for 3 marks. So now we need to explain why the holidays database is in third normal form. So it's already normalized, it's in third normal form. So why is that so? So first of all, there are no repeated attributes. So there are no repeated attributes. So there are no partial key dependencies. And all fields in each table are fully dependent upon their primary key. Right? And now we move on to the holiday company has several members of staff. The database has 2 additional tables to store the data about the staff, right? Your staff and schedule, right? So what do we have to do here? So we need to write an SQL script to display the first name and the second name of all staff members working on 220520. So we will have to use inner join here, right? So we're going to use select because we have to select and display them. I'm gonna write staff dot first name because we need to show the first name and the second name, right? So if you can see, this is how first name and second name are written. First name comma staff dot second name, right? So this is your selection statement. You're selecting this from staff, the table staff. You're inner joining on table schedule and on staff ID. So you're gonna write staff first table and its primary key, and the other table and its foreign key. So staff's primary key is staff ID and schedule's foreign key is staff ID. So this is how they are being joined, right? So you use the equals to sign and then join them, and we have to write where, because we have to display the working of a specific date. So where schedule dot work date equals to 22052020, right? And you have to end it with a semicolon because that is how SQL scripts work, right? And now we have to write an SQL script to count the number of people working on the morning of 26/05/2020, right? So we're going to use select again. We're going to use the function type of function count. I'm going to write staff ID. Sorry, this was not supposed to be in all caps. Staff ID from schedule, this is your table, and where work date equals to 26/05/2020, and we're going to use and here because we're finding the morning shift. So here, and morning equals to true, right? And we're going to end it with a semicolon once again. So this is your SQL script for part 2. Okay, so now a cake factory uses machines to make cakes, right? Complete the following descriptions of types of system. Write the correct missing term in space. So the factory uses a dash system to record data such as the number of cakes being produced each hour. So this is going to be a monitoring system, right? When the data collected from sensors are analyzed and used as feedback. So this is going to be feedback. It is a controlling system. One example of this system used in factory is to maintain constant temperatures in the oven. It uses a dash sensor. So it is maintaining temperature. So it's going to be a temperature sensor. Right. So this is going to be a temperature sensor, right? Okay. So now they have given us a diagram and we're going to read what's written. So a cake mixture is mixed in a large pot. A conveyor belt moves the cake tins beneath the pot. The conveyor belt stops and a set quantity of the cake mixture fills the cake tin. The conveyor belt then moves and another cake tin is positioned beneath the pot. Explain how the control system will ensure the correct amount of mixture placed in the cake tin. Sorry. Okay, so this is going to be a long one because this is for 5 marks. And if you're aware, if you have had CS in O levels, so this was a very good question that used to come every year, every paper, right? You need to describe how sensors and the controlling systems work together. And this was 3 marks in the sense, if you knew the method, it's going to be the same thing over again, just for the different type of sensors with a different situation, right? So first of all, as you can see in the diagram, so this is your there's a conveyor belt, and then you have the cake tins and you have this mixture stuff, all that stuff, right? So first of all, we can say that a pressure sensor is used. So pressure sensor is used to detect whether the tin is in correct place or not, right? So this is your point 1. So you're using a sensor to check if it is in the correct position, because if it won't be in the correct position, then the mixture will not, of course, go inside the cake tin, right? So that is your step 1. So if the tin is in correct position, so a message is sent to the microprocessor. Sent to the microprocessor. So what does the microprocessor do, right? So the microprocessor has to give out 2 commands in this specific scenario. The microprocessor tells the actuator 1 to stop the conveyor belt, right? So that is your first thing, that you're first gonna stop the conveyor belt. The second command is to tell actuator 2 to start pouring in the cake mixture, right? So this is what the actuator is gonna do for you. So first the microprocessor is gonna send them instructions, and that is what the actuators are gonna do for you. So you have 2 actuators in this sense. One is moving the conveyor belt and one is working with this cake mixture thingy, right? Okay, so now that you're filling in the cakes mixture, the pressure caused by the tin is measured continuously and compared with preset values. As soon as the preset value is matched. So what does it do? The microprocessor gives the command to stop actuator 2 from filling the cake mixture. Right. And then you can write on another statement that the other actuator is given a command to move the conveyor belt, and then this continues on, right, until you are done with the work for the day. Right. Okay. So now it says that the cake factory has servers that store its confidential recipes, right, and control the factory machines, right. Okay. Describe the implications of a hacker gaining access to cake factory servers. Sorry. So first of all, when you're getting access to one of the company's servers, right? So it has confidential recipes. So the hacker can get access to confidential data bracket recipes and release them online. It can also make the machines malfunction by stopping them, by giving them unwanted commands. And all this causes loss for the company. This causes loss for the company. Okay, so explain how the company could protect its data against hackers. So first of all, the biggest implication was that it will get the access to the confidential recipes on the server, right? So a firewall should be used, can be set up to block incoming signals that do not meet a certain requirement. Okay, so that is first step. Okay, so the other step is that even if they get access, right, so what can you do? So you can encrypt your data so that it means nothing to the hacker without its decrypting key, right? So that is step 2, right? Okay, so that is it. You are describing 2 methods, and 1 mark for naming the method, 1 mark for what you can do with it. So first of all is a firewall, the other is encryption. And as for firewall, you are setting it up to block signals and that do not meet a certain requirement. For encryption of data, so you are encrypting it so that it means nothing to the hacker because he won't have the decrypting key, right? Okay, so the machines have a counter to record the number of cakes filled each time a cake is filled. The counter is increased by 1. The value is stored in an 8-bit register. The current value is shown. Okay, so 1, 2, 4, 8, 16, 32, 64, 128. So it is much easier to use this, right? So our current value is 9, right? Show the value of the binary number after another 5 cakes have been filled. So 9 plus 5 becomes 14, right? So 1, 2, 4, 8, 16, 32, 64, 128, right? So 2, 4, and 8. 8 4s are 12. 8 plus 4 is 12. 12 plus 2 is 14, right? So the rest of them are going to be 0. So this is the denary number 14. Okay. The following table shows some assembly language instructions for a processor which has one general purpose register, the accumulator, right? And opcode, operand, and bitwise AND operation, bitwise OR operation, and all that stuff, right? Okay. So at the end of each day, the register is reset to 0, right? The assembly language statement to reset the whole register to 0. So to reset the whole register to 0, you can do AND 0. So even if, so first of all you need to understand the bitwise manipulation for AND. So if this is an AND, so 0 0 is 0, 0 0 0 1 is 0, and it's only 1 when both the inputs are 1. So let us assume you have this 8-bit register, right? We're gonna do bitwise AND with a 0 on this, right? It's gonna turn the whole of your register off, right? So it is resetting your register for the day, right? So you're doing it this way. You're performing bitwise AND operation of the contents with the operand. So and you're doing it with the number 0, right? Okay, so a two-place logical shift to the left is performed on a binary number shown in part 2, right? Or part D, sorry. So this is your, we are moving it 2 places to the left. So 8 will come to the 16, 8 will come to the 32's position, and 1 will come to the 4th position, right? So this will become 0 0 1 0 0 1 0 0. If you can look at it this way. So this moved 2 places, this moved 2 places as well, right? And it is saying that state the mathematical result of a one-place logical shift to the right on the binary number, right? So it is division by 2. Okay, so the factory servers run software that makes use of artificial intelligence, AI. Explain how the use of AI can improve the safety and efficiency of the factory, right? So first of all, machines can be used to work more efficiently as they can perform the same function tasks over and over again, and there are no drawbacks to that. They do not get bored. That is the whole thing. You can make them do tedious tasks over and over again and they won't have a problem with it, right? So, and the other part is that artificial intelligence can make use of their mistakes by learning from them and improving their efficiency. So that is what artificial intelligence does. They can do tedious tasks over and over again, and if they make a mistake, so they can reflect upon it, do not make it again. And when they're doing the same task over and over again, so at one point they might even increase their efficiency, right? Okay, so we have to draw a logic circuit for this expression. So this is not A or B or C, right? Okay, so you're gonna do A or B or C. So A or B or C, right? So we are doing a not here, right? So this is our not here. Okay, not A or B or C. So that is our first part. So B and C and D. So B and C and D, and then we are finally doing an OR between them, right? So this is A or B, this is A or B or C, this is not A or B or C, this is B and C, this is B and C and D, and this is finally your OR between these two, right? Okay, so now we have to complete the truth table for this logic expression. Okay, so this is A or B or not A or B or C, right? So how are we gonna go about it? I'm just gonna label this as D. So for a XOR, we need to be aware that XOR is only 1 when either of the bits are 1, right? So it's gonna be 1 here and with 0 on the remaining ones, right? Okay, And now we're gonna name A or B as E. So 0 0 1 1 1 1 1 1. Okay. And now we're gonna OR it with F. So we're gonna see E or F. Oh, sorry, E or C. So this becomes our F, right? So E or C. So 1 1 1 1 1 1. Okay, so we have arrived at this stage. Now we're going to do a knot on this because this is a knot. So we're going to turn it around 1 0 0 0 0 0 0 and 0. Okay, so we have arrived at here. Now we're going to do D or F, and D or F inverts in a sense. So D or, so 1 0 1 1 1 1 0 0, right? So this is how our logic gate turns out to be. So our answer is 1 0 triple 1, another 1 0 and 0. So this was for 4 marks, this was for 4 marks, right? And that marks the end of our specimen paper. This was in general easy paper. Just some things to point out. The networking part is really important in the sense that it made up 20 marks out of this 75 marks paper, right? And it comprises of a lot of things like how carrier sends multiple access collision detection, manages collisions, features hardware components, how packets are transmitted, what is a LAN, what is a static dynamic IP address, what is an IPv6 address, and give an example for that as well. So this is a very big section of your syllabus in the sense that it is something that you might not have, that is not a big thing in O levels, but in AS level, a lot of A2 content has been moved to the AS level. So it is a big thing, it is a big portion, and it's going to be a big portion for a while in the upcoming 9618 test. So thank you.